Looks like this person already solved this problem, but I wanted to work it out anyway in case a person had lingering questions or if other people have questions about this problem. So here we go. It says solve the triangle ABC if angle A is 41.5 degrees, side A is 183.6, and side B is 248.6. So this is what we call angle side side or side side angle, and it's the ambiguous triangle. Ambiguous triangle. Hopefully I spelled that right. So the idea that it's ambiguous because when you have a situation like this, I'll describe the situation, you have more than one possibility for B. So what we're looking at is the given angle is acute, and then you're given two sides. One side is opposite the given angle, and then you have a different side. But the side opposite the given angle is smaller than the other given side. And since the smallest side is opposite the smallest angle, and the next biggest side is opposite the next bigger angle, the biggest side opposite the biggest angle, then what we don't know is, would angle B be acute or obtuse? So, and this has to do with the whole fact that sine inverse returns values in these two quadrants. And so we don't know if it really belongs over here or not. We just wouldn't know that. So in this situation, we have to account for that. So we start off by using law of sines. And then we're going to say, okay, sine of 41.5 degrees over 183.6 equals sine B over 248.6. And we're trying to solve for sine B to see what is happening here. So sine B is going to be 248.6 times sine of 41.5 degrees over 183.6. So I take this and put it in my handy dandy calculator. 248.6 times sine 41.5. Make sure it's in degree mode. 83.6. And I get, oh, helps if I type everything in correctly. I have this weird answer, like that's not even possible. Okay. Oh, good. So I got 0.89720775559. They say go to 5 places, so 0.89720775559. By the way, when I'm doing problems like this, so this number in my calculator, it goes to that 9, but actually it goes beyond that. This is just what's displayed. So I like to store values in my calculator as far as possible. So now for the next part, B would be sine inverse of this 0.89720775559. And what the calculator returns when I do that is sine inverse, and I'm using the TI-84. Wish I could show you what I'm pushing here. But when I go up and highlight that previous value, and so that gives me the 63.79343244. Now, that's an acute angle, so, and that's obviously returning a value like here. But, so this is the 63.79. But that 63.79 could have been the reference angle. And it could be over there. So the actual angle could be this portion here instead. So what we also look at is 180 degrees minus the 63.79343244. So I'm going to do 180 minus that previous output, and I get 116.4 116.2065676. You see how it was rounded off to 116.21. So now, if we want to find the rest of this triangle, we can subtract in each case to get C. So in the first case, we have 180 degrees minus the A was 41.5, and the B was, in the first case, we'll go 63.79. We're just going to go to two places. And I do 180 minus 41.5 minus 63.79, and that's where I get the 74.71. That's what we have here. And I'll find the other one here as well, and then we'll come back and find the missing side C. So the other case, 180 degrees minus 41.5 degrees minus 116.21 degrees. So what do we get there? $116.21. I get 22.29. Okay, so this person rounded. Now, we find the missing side, so just use law of signs again. So what I'm going to do is first find this C1, so it would be C1 over sine of the angle C, that's related to it, 74.71 equals, and when I do this, I go back to the one that doesn't have any rounding, and that's our A. So A was 41.5, little a was 183.6, so 183.6 over sine of 41.5. So C1 would be 183.6 times sine of 74.71 divided by sine of 41.5. So 183.6 times sine of 74.71 divided by sine of 41.5. And I get 267.274127. And they wanted to go to two places. There you go, to the 27. And then we'll go on to C2. Do this again using the law of sine. So C2 is going to be sine of the affiliated angle, the associated angle, 22.3 degrees equals, again, 183.6, because this is our little a, over sine of 41.5, because that's our angle A. So what changed here was this, because that's the new angle for this other triangle. I want to point out that this is the smallest angle, so our C should be the smallest side. So it should be less than 183.6. I should just do an arrow. So C2, I should say, is going to be 183.6 times sine of 22.3 degrees divided by sine of 41.5 degrees. So in this case, 22 point, I'm going to say 29 because that's what I had. So I'm going to say this 29. I have an eraser. Dead air. Okay. And let's see what we get in this case. So I'm getting the 105.6 0.0956764. Now this is a little bit different than this, slightly different. I would take both answers. I didn't click on the little key to see what their actual answer was. There's some tolerance built into this. So I'm thinking, I almost feel like because I did round off here, I didn't put the full thing in, I got round off error here, which is propagated here. So, okay. Well, I hope that helps. And I know this was a little longer than people like, but I hope that explains that process for the ambiguous triangle. Just accounting for the fact that your angle, since we don't know if it was obtuse or acute, could have been either. And again, this occurs, just to restate it, it occurs when you have an angle and the opposite side and another side, such that the opposite side is smaller than the other side given. So that implies we don't know if this angle for the B is going to be acute or obtuse. So we have to look at both. Okay, good luck. Let me know if you have questions.